So this is the syllabus for the course. So we are going to get started soon here. Today's class is 2 hours class. So we will be done by 11:30. And these are the books. Professor Quinn already shared this with you, the syllabus. If not, I will share with you right now on the chat. And so essentially, these are the 3 books here we have, and all 3 books are already attached here, so you don't have to go purchase it. There's a Azure Analytics book that will help us learn the cloud computing. And then we have Cloud Analytics with Microsoft Azure. That's another book. And then we have the Practical Natural Language Processing. Okay, that's the 3rd book. And the way this course is going to go is we're going to learn the infrastructure and platforms. We're going to learn on Microsoft Azure. We are going to run how to process big data at scale for analytics and machine learning. We understand the wide spectrum of problem statements, tasks, and solutions approaches within NLP. We will learn how to evaluate various algorithms and approaches and demonstrate ability to build, train, model, and deploy NLP models using Microsoft Azure. So today's class is introductory class. So we're not going to go into. Okay, there's a message here. Please turn on your video. Okay, just a second. I'll start the video. All right, thank you, Dr. Quinn, for your suggestion. We are on, so basically 3 courses we have. These 3 topics we are talking about is the big data. We are talking about cloud computing on Azure, and we are talking about the NLP. Okay, so we're going to talk about cloud computing, big data, and NLP, natural language processing. And in today's times, NLP is changing the way we are doing our jobs, and the development in the industry today is going to push the boundaries of how natural language processing is being termed. It's going to change our jobs. It's going to change our life in general. That's a revolution that's going on out there in the natural language processing world. So from the, we see the excitement in the self-driving car today. That was due to the computer vision and sensor fusion, right? Now with the NLP, it's going to change the way we communicate, the way we do our day-to-day work, how we build our credibility, how we are able to do computing, right? It's going to change a lot of things because there's a lot of revolution going on in the industry right now in the NLP world, right? And today's class is more of an introductory class. So I'm just going to go over the various topics and introduce you to what is coming in the class, right? What's coming up in the class. And we are going to introduce the cloud computing concepts. We are going to continue introduce the other side of the coin here is the big data concepts. We're going to talk about big data. And we are also going to talk about the 3rd thing is the NLP. So I'm going to introduce all of these topics and encourage you to join this course, right? So that is the purpose of this class. And this is the syllabus. So we have the Azure Cloud introduction, then Data Lake, Data Warehouse introduction in Azure. We'll go through the HD Insight, Data Factory, Azure Databricks, Cosmos database, blob storage. We're going to go through whole data factory concepts. We're going to go through analytics concepts. We are going to go through several other items that are related to Azure and how to load data in Azure. How do you process data in Azure? A different type of big data ecosystem on Azure, and so on, right? So that's the That's the Azure Analytics and Data Pipe. And then week 5 and 8, we are going to, 5 to 8, we are going to go through natural language processing concepts like tokenization, frequency distribution, n-gram stemming, lemmatization, stop words, POS tagging, natural language processing, real world use cases of NLP, Python, NLTK, spacey libraries, syntax trees, chunking, chinking, and then context-free grammar. And then we will do applications like TF-IDF, like more indexing, count vectorizers, word embedding, IDF, inverse document frequency, the page ranking algorithm, multinomial naive Bayes classifier, confusion matrix. And we are going to go through feature extraction. How do you extract features? And then we'll get into the real holy grail of NLP today is the text summarization and generation, the natural language generation, natural language summarization. What is going on with these pre-trained networks like the BERT, ULM, GPT, GPT-1, 2, 3, Microsoft Turing NLG, we have Google's T5, we have fast text from Facebook, or Hugging Face is another one. So all of these are latest development in the NLP pre-trained models that is really changing the world today, right? And we're going to learn all of them, and we're going to go through a lot of these platforms like ARIA NLG platform or GPT-3 platform, right? We're going to go through that and understand how the NLP is pushing the boundaries of capabilities of how the languages are understood and the texts are generated. A few weeks back, Microsoft laid off all of their journalists in the Microsoft network, MSNBC, because they said we are going to have, not the MSNBC, but the MSN network, because they said all the news are generated through artificial intelligence. We don't need the editors and the journalists. The AI is going to create the articles. And then there are so many different platforms today where all the news are generated through AI. Same thing, you can imagine, let's say you want to write an article or a book, in fact, you can just start or initiate some sentences and the NLG engine will continue to write for you based on what you initiated. So you want to write about Shakespeare, you want to write about the 2020 elections in the United States, you want to write about the COVID-19 pandemic, it will just keep writing creative ways, much better than any human, highly paid human can write. Because it's been trained on trillions of objects, like hundreds and billions of objects, right? It's trained on that. Like, for example, for the ImageNet, for computer vision, it was trained on thousands and millions of object photos. And that's how the whole revolution in the image and object recognition started around 5 years back. Same thing is going on for last couple of years in the NLP world, where they trained it on all possible words and all possible sentences out there, billions of sentences, billions of trillions of words, and they are able to generate text now, right? That's a revolution we are going to talk about towards the end of the class. It's an 8 weeks class. So for 1 to 5 weeks is going to be big data, cloud computing, and the 5 to 8 weeks are going to be the NLP. Okay. And then we'll do the final project. We'll build a chatbot using Azure Cognitive Services. We are going to use Azure Search, Azure Q&A, Azure Luis platform for the cloud computing. And we are going to, that's for the chatbot, and we'll build the Azure using Azure chatbot service. We will build elaborate chatbot on any topic of your choice. That will be your project. We will also do project on speech recognition. So there are so many libraries out there for speech recognition. So I will help you create a speech recognition, the transcription, the emotion detection from the text and the tone of your voice. It will create emotions. It will generate that for you. Speech recognition and emotion detection from the tone of your voice, and also what you type, what you speak will be transcribed, and then we will understand the emotion from the text. Document summarization, right? We will do a lot of labs on that, on GPT-2, GPT-3, T5, fast text, and others. We will also do automatic text generation, right? That I was just telling you about, the data visualization from text. Okay, so now, for example, I can go to the area NLG. I'm just showing you, I'm just trying to excite you on the platform and possibilities. This is the natural language generation platform that I use. And here you see the demo here of a dashboard that is created through the natural language generation. Okay, so here we are able to show you all the different apps, right? And then here you see ARIA takes action against COVID-19 with 2 interactive dashboards. So here you see this is with Microsoft and John Hopkins. We are able to create a dashboard from pure text. So this dashboard, like what the syllabus says, the data visualization. So just by throwing data at NLG, it will create a map for you, right? And it will also create summarization. So today, this is a COVID-19 summarization on the right-hand side, and you have the map on the left-hand side. The NLG will write a localized update for you, right? So I can click on these buttons and it will show the headline in India today, 8% increase during previous week, 411,000 infections, right? A case increase, right? And then 61,000 deaths, okay? Right? It's 3 million cases and 61,000 deaths. So this is only for India, right? And then you're gonna see for other countries also as you navigate through that. And it's a navigable, so you can imagine the possibilities of what this type of technology can do for you. It has all these technology suite where you see the studio, business intelligence, apps, answers, connect, RPA, Excel. So ARIA natural language generation can do all of this just through speech or through text, through throwing in information, a vast amount of information. It's able to create all these things out of natural language generation. So you see the power. This is just tip of the iceberg. This is going to come to every company around the corner. There'll be a lot of startups, a lot of revolution, like you see in the self-driving car. The same kind of revolution is going to come in the NLP. That's why Dr. Quinn encouraged me to offer this course at CSTU so that it can enrich all of you, and help you, right? So what I'm going to do is I'm going to go over several concepts, first on Azure and then on the big data, okay, and then NLP today. So we are at 9:54. So maybe I'll give you a break at around 10:30, and then we will continue for another hour after that. Okay. So I'm going to paste some privileges for you. Okay. I'm going to paste some privileges for you here, that the material we are going to use for this class. And I'm also going to post it in the Google group, Google Drive that Dr. Quinn shared with me. I'm going to share all of that with you there. So just give me a moment. So I have shared all the material I intended to share here and also the privileges. Okay, so I'm going to share my screen now. And let me go to EduReka and show you what I mean. Okay, so once you log in, you will be able to go into the, so you are able to log in now, and then on the left hand side, you will see all the training material. So you see, are you able to see my screen?
Yes.
Okay, so you see all the material here. That's all the courses you have access to, okay? So this was one of the companies I founded many years back. So this is just, I'm just sharing that for today's class. And then you will have access to all this material if you join this training, okay? Here we are going to, and this is a comprehensive material. So we are going to go through Azure here, right, today. And we are going to go through some slides from there. We are going to go through the big data slides, a few of them here on the Hadoop and Spark. You see the Spark and Hadoop. And we are also going to go through the NLP slides. There's NLP material here. We are going to go through that also as an introduction, okay? So I'm going to go through all of that. Yeah, so it has all the material. This is natural language processing, right? So all of these courses are here. So you should be able to navigate through that. And I will go over all the material with you, okay? So that's the plan for today. We are gonna quickly go over all this material and introduce you what this class is all about, okay? So there are some chat messages, let me read that. And I will post the material to the Google Cloud CSTU, Google Drive CSTU right away, Dr. Quinn. Yeah. So I have also shared with you some slides. So please go over that. Okay, I will go over those slides also. Okay, but it's going to be very quick today because it's an introductory class. Okay, so what I'm going to do is I'm going to introduce myself first, and then.
Quick question, Dr. Mehta.
Yes.
Is there any conflict that everybody using the same user ID you provided and password?
No, there won't be any conflict.
So we okay, concurrent login with the same ID and password.
Yeah, it's a static website. It's not an application. So there's no problem. Yeah. So I'm going to go over the intro here. Okay. So you see my screen. So basically, I'm Bhairav Mehta, and this slide is a little old, but I'm a director of data science. They call it principal at Microsoft right now. I joined them around 4 months back. Before that, I worked for 10 years at Apple as a data science manager, as a data scientist, as a program manager for 10 years. Before that, I was at Qualcomm as a data scientist again, but at that time, data science word wasn't popular. The data science word became popular in 2010 when during a conference where one of the scientists coined that word in 2010 called data and science, called data science. Before that, it was called statistician or data analyst. Those were the words that were quite common, or data mining expert, right? So I had those titles before. So at Qualcomm in San Jose, and then Apple in Cupertino, and then I also worked at Philips LED, lighting as a data scientist, a computational physicist for quite a long time. We developed the first set of light engines for the televisions that you see today, the LCD backlight, LED backlight, and also for the projection. So I was a physicist there doing computational stuff. And then before that, I worked at automotive industry like Borg Warner, Ford Motor Company, as an industrial statistician in their factories, mainly trying to improve product quality through data science. So that is I'm an academician. I never leave school. I'm always enrolled in some course, some program in a university. I've gone to top universities in the United States, and I love to share my information, knowledge with students. And I've partnered with Dr. Quinn. I've taught a few courses with him in last year and a half, 2 years. And thanks, Dr. Quinn, to come back to me and invite me to teach this class. Yeah, so I love to teach. I teach almost 20 to 40 hours a week in different forums. And that's my passion, right? It's like you eat food. For me, teaching is like I get hungry to teach, and I keep teaching. Okay, that's my motivation and my hobby. So so we have around 25 students here, and we are going to continue where we left off, okay? So we won't be able to introduce each student here. We don't have time for that. But you may want to put your introduction in the chat so I know who has joined, okay? If you care about it. That is the point. And I'm going to go through the I'm going to go through the material now. So what is cloud computing today, right? Cloud computing has been around for a while, but what we are looking at these days is the cloud is growing very fast, right? You can see the companies like AWS and Microsoft Azure and other companies, they are doing very well today because of enterprise. Like 80%, 70% of enterprise have not adopted cloud yet. They are still in the phase of transitioning to cloud. And why Microsoft is growing so fast today is because of the trust. Who is going to trust? When they move from on-prem to cloud, who will they trust, right? Microsoft is a 45-year-old company. They have proven records, and governments, enterprises are able to trust them, okay? So we are going to go through the introduction to cloud computing, right? Here. So let's go through that first, and then we'll get into the some part of big data. Okay. So there's a message. Jennifer is saying, glad to meet you. Okay, very good. Thank you. Yeah, you can continue to type here. So I'm going to, very good. So I'm going to go through the introduction to cloud here, and then get into intro to big data. So, so AWS, I mean, I went to their headquarters in 2008. That was almost 12 years back. So I went to the campus of Amazon. Amazon was a much smaller company, just selling books at that time. And they had started this service called AWS. In 2008, I went to talk to them for a different type of position. And they said, hey, AWS is growing very fast. The stock price of Amazon at that time was maybe $70 or $60, I remember. So, so they've come a long way. And their biggest, push was through the cloud computing platform. They were the pioneers. They are the geniuses, pioneers who created cloud as a business. That is public cloud as a business. I mean, private cloud has been around. I mean, even many years back in 1990s, I used to work in a nuclear power plant in India. And there we used to use cloud computing, okay? Internally inside the power plant, we used to, because, nuclear power plants is usually not connected to internet because of usual security reasons. But we used to have our own internal cloud. But then AWS introduced this huge public cloud where anybody can go and log in and access, right? So another resource we are going to provide from CSTU is access to the, access to a cloud environment, right, to do the labs. But we don't expect you to have the cloud account because, I mean, you have to put your credit card number. You may not want to do that. So what I will provide you is subscription to Linux Academy, which is a free, not free, but I'm going to provide you as a sponsor access to the Linux Academy labs where you can go and do the labs, right? Other resources, Katacoda, I'm going to show you that later on. So you can imagine just in the first class, I'm giving you so many resources. to access, right? All these resources are available for you for free once you enroll in this class, right? So we're going to provide EduReca, we're going to provide Linux Academy for doing the cloud labs. We're going to provide the Cloudera, Cloudera HUI experience. It's a Hadoop user experience. We're going to provide that. So you'll be able to run a Hadoop code and MapReduce and other codes and the Spark code there. We are also providing you material. Dr. Quinn will send you books. And I already gave you the syllabus in that there are enough books in there too. And let me paste the syllabus here that I was showing you later on. So what is cloud computing today? Like, cloud is a collection of computing resources which are accessed through internet, okay? I don't have any way to gauge your experience as an individual student right now, because I don't know who have enrolled here, but I can tell you that all of you students, like maybe there are some students who are already certified in cloud computing, even they will get a lot of value out of this class, because I work at Azure. I work on Azure, right? On Azure Cloud, and I develop tools and technologies on Azure Cloud for security. Okay, that's my job. Apply AI for security on Azure Cloud. So I build widgets that eventually go on the Azure Cloud. So you will be able to use all of that, right? You'll be able to use all of that. And at the same time, you'll be able to have the cloud computing resources, right? And able to learn a lot, insider scoop of what Azure Cloud is all about, right? So, you have collection of computing resources which are accessed through internet, okay? And then you have cloud computing, you have public cloud or hybrid cloud or private cloud, AWS, Azure, and Google Cloud. All three provide all that resources to you, right? Google Cloud Computing is use of software and hardware to provide services like storage, VM servers, many more over the network. With the cloud computing, users can access files and use applications from any device that can access internet, okay? So that is the cloud computing, right? So for example, right, AWS have cloud resources, right? The hardware at 5 or 6 locations in United States, in around 40 locations in around the world, and then they have edge locations also, right? So they are the most mature environment today, right? Cloud and cloud offerings. Azure is not far behind. Azure has the most machines, terminals in the world. They have around 2 million nodes, they call it, nodes that are computers, different capacity, different capabilities, right? So that's why you want cloud computing, because I remember I used to work in at Qualcomm around 15 years back. I moved to the Bay Area from Boston, and I used to work on Junction Avenue in San Jose at Qualcomm's. One of their divisions that developed the Snapdragon that is in every Samsung or any Huawei or any other phones today. So we developed the Snapdragon at that time, 15 years back. I used to work there, and we used to have our own server room in the basement of the building on Junction Avenue. And we used to go in there. I used to be, as a scientist, one of the scientists, told me that, hey, Bhairav, why don't you manage this few nodes in this data center and few routers? So I used to be administrator. I was just young college graduate at that time. So he asked me, like, you do this, right? So I used to manage it. And, I mean, it was so difficult task to do it myself. I had other duties too, in the top of managing that data center, which was like only 12 or 13 blade servers there from HP at that time, and some Cisco routers and switches. And that was running all of that building's compute needs, okay? So we couldn't focus on core business, because I couldn't do my other job many times because I was maintaining the server. right? There are some messages here. Let's see if they are relevant. Okay, very good. Thank you for guys for introducing yourself. Okay. Yeah, so you focus on core business, fast service provisioning. So you will see we will start some Azure virtual machines, and you will see how quickly it can be spawned. And then it's cost effective eventually, right? Initially, you will feel that, hey, it's very expensive to use cloud. But as your company grows, as your business grows, as your usage grows, eventually, and your needs grow, so if it's a Black Friday, or it's like a big retail event, you're going to have a lot of customers like Cyber Monday. A lot of customers are going to go online and purchase items. So at that time, you need a lot more compute resource. But for that one day, you're not going to buy $1 billion of computers. You just need it for a few days, like maybe a week. So you can just go to cloud and get those resources and then shut it down. Then there are service models like infrastructure as service. You have platform as service. So what is infrastructure as service? AWS is very good at this, right? So around 5 years back, I went to this conference in Las Vegas called AWS reInvent conference, right? The AWS reInvent conference was all about, all about AWS innovation. It was a 4 or 5 day event, and it was attended by 90,000 attendees. It's the biggest event I've ever attended in this country. I've attended other events in India where you have, hundreds of thousands of attendees, but in United States, that was one of the biggest event I've attended in my time here in the United States for the last 20 some years. And, infrastructure as service was something I learned, that AWS is so good at infrastructure as service, nobody can beat them. Web servers, databases, application servers, messaging services, storage, network, all of these unicorn apps are hosted on AWS because you are able to scale very fast. Then comes platform as service. Google is very good at platform. That's why even when we started, it used to be called, Google Cloud Platform, called GCP, for developing, delivering applications. Google is very good at that. They have some of the best APIs out there. Okay, in machine learning, AI, in big data, they are the pioneers in those things. After Yahoo Labs, they are the pioneers in this area. Okay, that's a platform as service. And then what you have is SaaS, the software as service. Okay, software as service is a SaaS. Okay, Microsoft is very good at this. Okay, they have software as service on the cloud, and Microsoft 365, the Office, Dynamics, the Power Apps, the Power BI platform. That's all, application as service, software as service, and they are very good at those things. Okay, so then you have the iSPaaS and SaaS. There are companies, they try to do each other's job these days. So Microsoft is going into infrastructure, Google is going into applications, software, and AWS is trying to get into enterprise. So all of these guys, and IBM in the middle, they bought Red Hat, and now they are also trying to push their boundaries and getting into all of these, right? So you have all 3 or 4 of them out there. Okay, so then you have the cloud computing service models, like on-premise, infrastructure, platform, and software. So you have on-premise. When you have on-premise, like I was telling you at Qualcomm in 15 years back, we used to have everything on-premise. We used to have network, storage. There's some messages here. Okay. Yeah, so right now, the course that is available on Azure for you is AZ300 and AZ301. That's the Azure Solution Architect certification. But they also have Azure Machine Learning certification. So you'll be able to qualify for all 3. But they keep changing the numbers, so the current numbers may be a little different. Until end of last year, AZ300, AZ301, those were the 2 were for solution architecture. Expert, right? Expert level. You have associate and expert level. And then there was also another service which was more around machine learning, Azure machine learning. So you'll be able to certify for that. Okay. Okay. Very good. Yeah. So you have your infrastructure as service, platform as service, and software as service. So you see when you go from one to the other, an issue. Okay. Now that is fixed. So I'm going to start sharing, and sorry about that. So we are going to thank you for Jennifer for helping with the logistics. So we are going to start and continue the cloud computing part. Okay. So as I said earlier, you know, what is different between IaaS, and SaaS, and then the next thing is cloud computing deployment models. It can be a public cloud like AWS, Azure, or Google Cloud, or IBM Cloud, or Oracle Cloud. So you can have a public cloud where anybody can log in and start a machine, or a private cloud, or a hybrid cloud, or a community cloud, right? So companies like Kiva and United Nations and stuff, WHO may have the community cloud of their own. Hybrid cloud, Microsoft is very good at hybrid clouds, and they do a very good job at the hybrid on-prem versus cloud environment. So they are able to run the hybrid cloud, right? It's a combination of private and public cloud. It's scalable and cost effective. And then, we'll go through the introduction later on. So this is the introduction to the cloud environment. So the next we are going to do is we are going to go through the big data part, right? There's a big data part, and then we will build some instance in Azure. Okay, so we'll show that later on. So right now we are going to go through the big data introduction, and then we'll get into, we have 1 hour left or so, one hour or so. So we are going to go through that that information here. Okay, so that's the big data introduction. So what has happened in last few days, last few years, is that the big data is quite prevalent. So there was this version 7 of data in 1 minute, and right now, there's exabyte or yottabyte of data, generated every minute. Okay, there's so much data being generated every minute from your smartphone, from your tablets, from your computers. So yesterday I was talking to this company called AC Nielsen. AC Nielsen, they get data from all the different retailers like Walmart, Target, you name it, right? All different retailers send them data, and AC Nielsen gives them benchmarks index, benchmark statistics, okay? And they give them all that information, and at the same time, what AWS, what Walmart gets is the benchmark data, is where they sit versus the other competition sits, and that based on that, they know that how their penetration is working today. In this case, what is big data is a term of collection of data sets so large and complex that it becomes difficult to process using in-hand database management tools. So the big data has been around for last 5-6 years. We are seeing a lot of buzz around that. And most of the data is unstructured in this area, okay? So most of the data is unstructured. So when I say unstructured means that, so the data is unstructured, is all text. People chatting with each other, people talking like spoken language, right? You have a lot of recording of that. You have features created from images, videos, face detection. Yesterday, Amazon came out with this device called Halo. Halo is a device which has microphone and speakers, and also have camera. All of that is there. Okay, so you have all of that, and it's going to track you, right? It's going to track your fitness. It's going to track your vitals. It's going to track how you feel. It has a camera too, so it's going to watch you. So all of that is going to help you build up on your capability or your health or all the different aspects of things that you care about from your personal details, right? Like the Apple Watch keeps maintaining your, a lot of your vitals and tells you to stand up or start breathing every so many hours because it feels that your oxygen concentration is going down. So all of that is big data, right? All of these devices are creating all this data for you. And unstructured data has grown a lot, right? You're talking about 40 zettabyte. Uh, so they have these 5 V's: volume, variety, velocity, value, veracity. So all of this is a concept of big data, right? And how that entails with the NLP today is because most of the data is unstructured. Most of the data is not in the realm of like spreadsheet, right? You can't analyze the data on a spreadsheet. It's all available on unstructured, in voice, in text, in people clicking, people touching the app, and data is coming at very high speed, right? So data is coming at very high speed, and you're not able to catch up with it, right? So that is the other aspect of velocity, right? And the value is also there, right? Find correct meaning out of the data, right? That is also very important. And the veracity is uncertainty and inconsistencies in the data, right? So what we are looking at is the big data introduction. And there are some big data customers, you have the, China Mobile, eBay, you have NetBio, JP Morgan Chase, Sears. And then, many years back, Yahoo Labs and Google and all these guys pioneered a concept of big data through this thing called Big Table Paper. Big Table Paper explained how Google analyzes its data through mapper and reducer, right? And then Stanford University and Berkeley, AmpLab, and others, they created this in-memory compute environment called Spark, where it utilizes memory on your computer and gives you in-memory compute capability so that you can cache all the data on the memory and process it super fast. Okay, you can efficiently manage your memory. Okay, so there's a hot path and cold path. The cold path is more data at rest. Hot path is hot data that is last 1 day, 2 day, 5 day, 1 week, right? And then you have the distributed file systems where you have one machine, vertically integrated, vertically scaled machine will take all of this information. But if you have 10 machines like that, you're gonna be able to multiply that concept, that distributed file system concept, right? You're gonna multiply your capability, okay? So that is the big data concept here. And Google came out with this concept of map reduce. And that is what the big data started with 5 years back. So it had several tools like Hive that was written by Facebook, Pig was written by Yahoo, you had Spark, you had Impala, you had HBase from Google. So all these companies had open source the environments, open source their code to give you the experience that is popular today. Okay, but then came Spark and Flink and so many new tools that really enriches the way data is analyzed. For example, you have text data coming in, right? The text data is coming in, and the text data is letting you log in, right? And you are able to take the text data and analyze it. How do you analyze text data? You create features from the text data. So let's say I say that I'm excited to teach NLP cloud course at CSTU. So that sentence, has several words, and each word may be appearing multiple times in a sentence. So I can count how many times the words are appearing, and then I can divide it by number of words. That's one feature I created from a text sentence. You can also have You know, you can also have document frequency, right? Where you do log of that and try to, or do a cosine similarity, right? You like find similarity between documents. These are the ways you quantify the words. So what happened a few years back, around 3 or 4 years back, was one of the scientists at Google. He said that you know, all this frequency and bag of words, they call it, right? It's very rudimentary. It's not, you're not able to get the gist of the words. You're not able to keep the grammars intact. It's not correct language. You have all the kind of issues. So then they said, okay, we're gonna hire all these grammar experts. So they hired all the grammar experts, and they said, okay, we're gonna put rules in the language models, and we're gonna say, we're gonna have rules that, okay, you know, if what is the proverb, what is the noun, what is the adjective, and how they are positioned, and you know, where should they appear, right? And what are the rules of English language or Hindi language or Mandarin language, all the different languages, they came up with the rules. But they could only do so much. They had to hire so many experts in grammar to create those corpuses, those rules. They said that's not scalable. We have so many languages in the world. We can barely do 2 or 3 languages in 1 year. Then they said, okay, we are going to go out and go to all the governments of the world, and we are going to ask them, can you share with us? Because like countries like Great Britain or France or you know, Netherlands or you know, Spain, they had colonized many countries in early 1900s and early 1800s, and they still have relationship with them. So whatever the government speaks or publishes, it gets translated by experts into 20 different languages, 30 different languages, based on the Commonwealth of United Kingdom. So all of that translation, Google took all of that copy of the translations. They took it, right? And what they did was they took that translation and they said, we're going to use this translation and train our machine learning language models to translate. But that was not enough, because they could do only direct languages like English to French, English to Hindi. They could not do like some regional languages, right? They could not do it like you know, there's a regional language in India called Telugu. If you want to go from French to Telugu, first you have to go from French to English, and then English to Telugu, right? So those were the challenges they were facing, and they said they could do only 15 languages like this. They said we want to do hundreds of like tens and tens of languages. So the scientists say that, okay, we can create encoding routines from the sentences. So for example, when you look at an image, you have pixels, and each pixel has a value, intensity value or binary value, right? Each pixel can have, and that value can be used to train. Similarly, they said we are going to have languages of sentences. We can create embeddings. Okay, so they said they're going to create this type of embedding. Okay, so this is called projector.tensorflow.org, and they created this embedding map for every word in Wikipedia. Okay, so this is called embedding map. They can say embedding projector. They created embedding projectors, and they are able to see how the words are situated in a projection, right? And they found various different ways to map this. This is the TSNE, right? So this is 10,000 words from Wikipedia. They did it on like, you know, hundreds and thousands of millions of words, and they were able to create this type of maps. And that's how that's based on pure numbers. So each, in this case, it's a humans can watch only 3 dimensions. So we are only seeing 3 dimensions, but you can have 500,000, 5,000 numbers for every sentence, every word appearing in a sentence in the context. That's a concept of word embedding. Okay, so word embedding came through as a concept many years, like 3-4 years back, and that really changed the way languages are understood. So for example, let me share with you this particular link here that I'm showing you. Okay, so this is a projector.tensorflow.org, And this is the concept. Let me share this concept with you. So this is the story I just told you is right here. Okay, so I'm gonna share my screen now, and I shared the link with you. So this is the story I was just telling you from this Medium article. So this is a translate story that I just told you. And what this is showing here is what is the bleeding edge development today, okay? This is a bleeding edge development. So from an image, you can encode the image and convert it into numbers like this. This science has been around for a long time. But can you do this? Have a sentence and have set of numbers for it, okay? So that's the NLP, development that you are seeing today, okay? A lot of interesting things are happening in this area because once you are able to quantify at this high granularity level, right? Once you are able to quantify at this high granularity level, you are able to run a lot of things because now you have numbers. Like we all know how to play with numbers. Human being, as we are programmed, we are very comfortable with numbers versus languages. Because historically, languages have been, it's a tribal thing. It's not scientific. Nobody thought about what Barrow Mehta will do in 2020 when they wrote a language in 1600s, even before that, right? So it was very tribal thing, right? And it was like the grammar as as a discipline, came out from France and UK. Those grammatists, the grammar experts of those days, they wanted to discipline everybody, how they write, how they speak. So they said they are going to they are going to keep it, they're going to keep it in such a way that you are running through, so we're going to keep it in such a way that we are always, everybody writes similar language, similar rules. They follow the rules, and they were penalized if they don't use the right grammar. Okay, so those are the old days. But today, that is a big painful thing because now, languages can be perceived differently, spoken differently, different dialects. So all those things have to be taken care of. But if you are able to quantify it, now you are able to correlate information because a word in English and word in Hindi are going to have similar scores. Okay, so so this is what happened, right? You start from the left, go to the encode process, and then you decode on the other end. Okay, that's how you translate. So here you have English coming in from one side, it's creating embedding sentences. So you are able to do this, right? You are able to do this. So what I want to do is I want you to go over, Eureka now, and we'll go over the NLP part. Okay, the NLP part. So here we have slides called natural language processing, and we have slides also. I shared these slides with you on the on the Zoom. So you should be able to go through the slides. So this is what we're going to talk about next 20-30 minutes we have left. Okay. So we are going to go over a few of these slides, and we are also going to go over the natural language processing slides in Eureka. Okay, so that's your Eureka slides here, and we can go there and go over the slides. So what I want you to do is just open these documents, the two documents, and I'll be back in 2 minutes. Yeah, so what we are going to look at now is the text mining NLP concepts. Okay, so that's what we are going to talk about, and here we are going to go through the content, the presentation here, and all of these courses also have the labs in it. Okay, so you are able to run that through. So what is text mining, right? Text mining concepts, right? There are several several different topics. Okay, several different topics in NLP. NLP has been around for a very long time. Almost 10 years back, I took a course in NLP. Okay, I believe it was at UMass Amherst. I took a course in NLP around 10 years back. So it has been around for a very, very long time. Um, but the latest development in NLP is because of the culmination of big data, algorithms, machine learning, all of these things kind of culminated together to bring in the NLP revolution that we are in today. Okay, so so basically, what you are looking at is the text mining is the process of deriving meaningful information from natural language text. Text mining usually involves the process of structuring the input text and deriving patterns within structured data. Okay, so need of text mining is, with advancement of technology, more and more data is available in digital form. So it has become essential to develop better techniques and algorithms to extract useful, interesting information from this large amount of text data, right? So text mining refers to processing of deriving high quality information from text. Okay, the overall goal is essentially to turn text into data for analysis, the application of natural language processing. Okay, so you have NLP, and what is NLP, right? A chatbot, let's think about chatbot that we're going to build as part of our project in this course. So, you have your conversational things going on your phone, you're chatting with your friend, or you have an intelligent bot that is bringing into your chat, and it's interacting with you. Or you are calling Apple today, and Apple, there's nobody on the other end. There's some bot sitting there, and you're going to ask questions that my iPhone is not working. Can you help me? And then the bot is going to go in and find and help you, right? And go step by step based on your questions. It's going to ask you how you're going to solve it, right? And then slowly and surely, eventually, it will help you solve your problem. I had a Bose headphones, and I had a problem with my Bose headphones. So it was not pairing after I upgraded the software on the headphones. And what happened was I went to the chatbot on Bose because they didn't even have a phone number. I could not even call anybody. So I went to the chatbot, and I put the serial number of the device. It showed me where to find the serial number. So I put the serial number of the headphone, and then slowly it told me what to do, press which button, and it connected to that bot connected to my headphone, and eventually fixed the problem, right? So that's the example of a chatbot. So you have a knowledge base, that's the source content, all the information that you need. And we have storage of interaction history because they want to keep it for improving the NLP, the chatbot experience. And you have the NLP layer in between that is creating this experience for you, right? So there's a knowledge base. It contains a database of information that is used to equip chatbots with information needed to respond to queries of customer requests. And then you have the data storage. It contains interaction history of chatbot with users. And you have NLP layer. It translates user queries into information that can be used for appropriate responses. An application layer, it's application interface that is used to interact with other users. What are the applications of NLP? Speech recognition, as the syllabus said, text classification. So for example, I use chatbot and I use NLP to route to route all the different calls, right? So I want to route the calls to different departments, different individuals who are expert in operating system or networking or application development, right? So this chatbot usually helps you do that, right? So that's the concept of text classification. So living room with a couch and a television, a man riding a bike on a beach, a man. So this is captioning from the video, right? It's able to do automatic captioning. Machine translation, right? I showed you my messaging bots. All these are NLP applications, right? So then we'll do all the labs in the class. Here we don't have time for that, but all these activities can be done using Python. So we're gonna learn Python, and make sure all of you are able to run the labs and do all the activities needed to complete, right? So then comes the NLTK, right? NLTK has been around for a while, but what we are doing here is from Stanford, right? NLTK, Natural Language Toolkit from Stanford. There are other toolkits out there like Spacey, there's GenSim from Czech Republic. They are the pioneers in language understanding way before Google or others came in, right? So NLTK is one of the labs, one of the packages we're going to use in this course. And these are all the libraries, you know, NLTK libraries, you know, you can do stemming, lemmatization, you can do tokenization, you can do name entity recognition, you can do a part of speech tagging, you can do a lot of these activities that are quite common in NLP, right? There are several things that we're going to learn in this class, right? Then we're going to learn extract and cleaning, analyzing sentence, text classification, and then this will lead to chatbot development, okay? The Q&A development, the Louise framework from Azure. We're going to learn all of that. And then that's where we will go into this, particular set of slides that I shared with you, where we're going to go over what is natural language and what are the tasks that are performed, right? So let's say, from a natural language perspective, as an interpreter, first you do the lexical analysis, regular grammar, then take the tokens out from there. And then you do syntactic analysis called parsing, the lexing and parsing, okay? Regular grammar, word rules versus context-free grammar, sentence rules, okay? And then you build a tree around that, right? So ambiguity is required for understanding when communicating between people with diverse experience, okay? Natural language processing requires flexibility, which generally comes from machine learning. For example, a fast cat wears no hat, or a cat in the hat ran fast. So you can count, you can put all these documents and create this type of word frequency, a word of bag of words type of model here, and able to create frequencies and count, okay? You're able to, then language is predictable usually, right? Because there was a ton of traffic on the beltway, so I was late. At beach, we watched the waves. Watch out for that car or watch out for that dog, right? So you can predict. Languages are very predictable, and NLP leverages this concept and this capability. You have boat, ocean, seafood, steam, crab, beach, sand. The models predict relationship between tokens, right? Right, and then but they can't understand meaning of it. So tokens are not equal to words. Tokens are substrings, only structural data, right? Versus objects. Words are objects, contain sense and meaning. Bearing, shouldn't, or to bear, should, not, right? Those are words versus. So that's why we have this name entity recognition. We have NER. We have the part of speech tagging, and that creates a tree of all of these words and what do they mean in English. NLTK is the state of the art, right? It's academic design, relies on formal models of representation. Models are adapted, augmented through probabilistic methods. Small number of algorithmic comprise the standard framework, right? So these are some of these traditional NLP applications, like summarization, reference resolution, machine translation, language generation, language understanding, document classification, author identification, part of speech tagging, question answering, information extraction, information retrieval, speech recognition, sense ambiguation, topic recognition, relationship detection, name entity recognition, right? So if you work for a large corporation, information is king. That's where politics come in, right? But in this context, you have data, you build information from it, and eventually you get knowledge from it, right? So that is the concept of NLP. You are trying to get knowledge out of data. Data is people talking, people typing, textbooks, you name it, right? Reviews, people writing reviews on Amazon, people writing reviews on Rotten Tomato, people writing reviews on Ebert and Siskel, right? So all of that, you should be able to get sentiment out of it. What are people thinking about me? So I consulted with this company many years back called Clarabridge. The Clarabridge is customer experience management company. So what they do is they take brands and for every brand they have every hour, they have a meter. Okay, what does people think about Marriott brand in Boston, Massachusetts? What do people think about Hyatt in Shenzhen, China, right? So it it always measuring the sentiment, the climate model, right? So it's measuring the sentiment. Okay, people are Grand Hyatt at Shenzhen. People, all rooms are booked. There are thousands of people living there, staying there for a night, 2 nights, 5 nights. And what do they think about Grand Hyatt Shenzhen, right? What do they think about it? I mean, do they think positively about it? Do they think negatively about it? Brands would want to know how they can improve, because when somebody pays $1,000 a night or $500 a night, they would want to know what they think about their brand, because they want them to come back, because there are very few people in the world who are going to spend that kind of money, right? So so they want to know what do they think, how they can improve, right? So you have phonology, you have morphology, you have syntax, semantics, and reasoning. This is NLP pipeline. So you speak, you have speech analysis, speech synthesis, pronunciation model. Then you have morphological and lexical analysis, or realization, morphological realization. That's the morphological rules. Then you have parsing and syntactic realization. That's a lexicon and grammar. Then you have semantics, which is contextual reasoning, utterance and planning, discourse context. And then you have domain knowledge, which is application, reasoning, and execution. Okay. So what you're looking at is the morphology, the study of the form of things, words in particular. Consider pluralization of our English, orthographic rules, puppy versus puppies, morphological rules of goose of geese or fish. All right. Major parsing tasks like stemming, lemmatization, tokenization. This is called chunking, right? Or parsing, feature parsing, grammar. So you're able to get this information. Semantics, study of meaning. I see what I eat what I see. He poached salmon, right? Frame extraction, right? Thematic meaning, right? TMRs. The man hit the building with a baseball bat. So this is name and meaning representation, thematic meaning representation. Your human agent, strike, physical force, habitable structure, sports equipment. These are man hitting the building with a baseball bat. And then you have NLP application like Yelp Insights, Jeopardy by IBM Watson, computer assisted medical coding, geoparsing, author identification, sentiment analysis, language detection, event detection, Google Knowledge Graph, machine translation. All of this applications are big data, right? Examples are easier to create than rules. Rules and logic miss frequency. More data is better for machine learning. Knowledge engineering is not scalable. And computational linguistics methodologies are stochastic. So then comes natural language toolkit, NLTK, we talked about it. And then it goes into examples of NLTK, right? These are the guys. And you see that a lot of really good work comes out of Australia, right? In NLP today, okay? This book was written by Stephen Bird of University of Melbourne, right? In Edinburgh, University of Edinburgh. Batteries included, it's the corpora and algorithms ready for research. And you have the NLTK is not production ready out of the box, lightweight, generally applicable, magic. There are actually a few things that are production ready right out of the box, right? So this is ready production. So you're gonna do segmentation, tokenization, part of speech tagging, wordnet, lemmatization, stemming, n-gram. So these are all the jargons of NLP experts. So today, there are so many jobs in this area. Both like Dr. Quinn has really hit the nail right where it needs to be hit, right? These two concepts of cloud and NLP are so much demand. Every other application, so you talk to KPMG, you talk to Goldman Sachs, you talk to Accenture, you talk to Deloitte, you name it, right? Microsoft, Amazon, everybody is building some kind of speech assistant. They are building some kind of conversational bot, right? It's a very hot area. So if you are able to learn these skills, you are very well marketable in the industry today. So if you're gonna do Azure or AWS or Google Cloud, doesn't matter. We're going to focus on Azure in this course because I believe, and I will be biased a little bit, I work at Microsoft, Azure has the best chatbot environment today. They have the best NLP libraries. Microsoft, Google, and few others, they are neck and neck in the development of natural language generation pipelines, okay? So we're going to go through all of that. All these words we'll learn, we'll do examples through that. You can go over all the material that I have shared with you and see the value of this material. It's a lot of material I've shared with you. And I will also post all this material on the Google Drive that Dr. Quinn shared with me, right? And then comes the generation part, okay? So let me show you a demo of summarization and generation, okay? So these are all the different Python libraries. Everything is done in Python. We'll learn all this, right? And how machine learning can be applied and how NLP can be used for machine learning, okay? So that's the concept. Let me show you a demo of summarization. Okay, so we're gonna start this lab.
This is 2-minute papers with Dr. Karo Jona Ifahir. In early 2019, a learning-based technique appeared that could perform common natural language processing operations, for instance, answering questions, completing text, reading comprehension, summarization, and more. This method was developed by scientists at OpenAI, and they called it GPT-2. The goal was to be able to perform this task with as little supervision as possible. This means that they unleashed this algorithm to read the internet, and the question was, what would the AI learn during this process? That is a tricky question. And to be able to answer it, have a look at this paper from 2017, where an AI was given a bunch of Amazon product reviews, and the goal was to teach it to be able to generate new ones or continue a review when given one. Then something unexpected happened. The Finnish neural network used surprisingly few neurons to be able to continue these reviews. They noticed that the neural network has built up a knowledge of not only language, but also built a sentiment detector as well. This means that the AI recognized that in order to be able to continue a review, it not only needs to learn English, but also needs to be able to detect whether the review seems positive or not. If we know that we have to complete a review that seems positive from a small snippet, we have a much easier time doing it well. And now, back to GPT-2. As it was asked to predict the next character in sentences of not reviews, but of any kind, we asked what this neural network would learn. Well, now we know that, of course, it learns whatever it needs to learn to perform the sentence completion properly. And to do this, it needs to learn English by itself, and that's exactly what it did. It also learned about a lot of topics to be able to discuss them well. What topics? Let's see. We gave it a try, and I was somewhat surprised when I saw that it was able to continue a 2-minute paper script, even though it seems to have turned into a history lesson. What was even more surprising is that it could shoulder the 2-minute papers test, or in other words, I asked it to talk about the nature of fluid simulations, and it was caught cheating red-handed. But then it continued in a way that was not only coherent, but had quite a bit of truth to it. Note that there was no explicit instruction for the AI apart from it being unleashed on the internet and reading it. And now the next version appeared by the name GPT-3. This version is now more than 100 times bigger. So our first question is, how much better can an AI get if we increase the size of a neural network? Let's have a look together. These are the results on a challenging reading comprehension test as a function of the number of parameters. As you see, around 1.5 billion parameters, which is roughly equivalent to GPT-2, it has learned a great deal, but its understanding is nowhere near the level of human comprehension. However, as we grow the network, something incredible happens. Non-trivial capabilities start to appear as we approach 100 billion parameters. Look, it nearly matched the level of humans. My goodness. This was possible before, but only with neural networks that are specifically designed for a narrow task. In comparison, GPT-3 is much more general. Let's test that generality and have a look at 5 practical applications together. 1. OpenAI made this AI accessible to a lucky few people, and it turns out it has read a lot of things on the internet which contains a lot of code, so it can generate website layouts from a written description. 2. It also learned how to generate properly formatted plots from a tiny prompt written in plain English. Not just one kind, many kinds. Perhaps to the joy of technical PhD students around the world. 3. It can properly typeset mathematical equations from a plain English description as well. 4. It understands the kind of data we have in a spreadsheet, in this case, population, and fills the missing parts correctly. And 5, it can also translate a complex legal text into plain language, or the other way around. In other words, it can also generate legal text from our simple descriptions. And as you see here, it can do much, much more. I left a link to all of these materials in the video description. However, of course, this iteration of GPT also has its limitations. For instance, we haven't seen the extent to which these examples are cherry-picked, or in other words, for every good output that we marvel at, there might have been 1 or a dozen tries that did not come out well. We don't exactly know. But the main point is that working with GPT-3 is a really peculiar process where we know that a vast body of knowledge lies within, but it only emerges if we can bring it out with properly written prompts. It almost feels like a new kind of programming that is open to everyone, even people without any programming or technical knowledge. If a computer is a bicycle for the mind, then GPT-3 is a fighter jet. Absolutely incredible. And to say that the paper is vast would be an understatement. We only scratch the surface of what it can do here, so make sure to have a look if you wish to know more about it. The link is available in the video description. I can only imagine what we will be able to do with GPT-4 and GPT-5 in the near future. What a time to be alive! What you see here is an instrumentation for a previous paper that we covered in this series, which was made by weights and biases. I think organizing these experiments really showcases the usability of their system. Weights and biases provides tools to track your experiments in your deep learning projects. Their system is designed to save you a ton of time and money, and it is actively used in projects at prestigious labs such as OpenAI, Toyota Research, GitHub, and more. And the best part is that if you have an open source, academic, or personal project, you can use their tools for free. It really is as good as it gets. Make sure to visit them through wmb.com/papers.
Yeah, so you saw that, what I was trying to show you, you saw the...
Yes, we can see the video, yes.
Okay, all right, very good. So you could see you could see the development that is there in GPT-3. I will share the link to the video here, so all of you can watch it on your own. So all of you should be able to see this, right, and make your decision on the course. So you're most welcome to enroll. There's a lot we can talk about, but we are out of time. It's a two-hour course. The real course will be 3 hours, and we are going to develop a good knowledge for all of you based on the video I shared with you. Based on the video I shared with you, you are able to see the capability and the amount of job that this GPT-3 is going to create. So all of you, it's essential to have this knowledge for all of you today. Okay, thank you everyone. Thanks for your time. So Dr. Quinn, I will leave now. Thank you.